My name is Medhi Khoury. I work at the University of Exeter in the United Kingdom, and I'm a specialist in modeling cascading failure of infrastructures. That is to say, when you have a sandwich of interconnected critical infrastructures, let's say a network in blue, there'll be water, another network in red, that would be power. And if you shut down a power node somewhere in there, it might have an impact on the pump that brings you water, which in turn might have an impact on the cooling that impacts some other things in the electric grid, and so on, so on. So failure literally cascades through this interconnected system. So my specialty in the context of this project is I'm making the model that capture this cascading failure effect of critical services. And at the same time, I'm also specialized in producing serious games. So I'm gonna make, it's already done, I'm gonna make a cascading failure engine that simulates all that. And I'm gonna connect it to an interface with a serious game in which you're gonna see a town, a toy town of some sort, or perhaps even a real town, and then see what happens when things are shut down because of flooding, because of other things, and then see the consequences. What happened recently in Greece, in Volos, and also what happened in Libya was really, really impressive and surprising, and also very dramatic. And this kind of event normally would have been totally unprecedented, but with climate change, we might have to expect this to happen more and more often. And this leads us just right now, literally this week, to revise our simulation in order to prepare to simulate what would happen with the failure of critical services in case of such rainfall. We are now looking at the type of event which normally would only happen, would have a chance to happen, 1 in a 10,000 chance to happen. And we are now considering this kind of event. Before, we would look at events which would be 1 in 1,000 chances to happen. So this is where we are going because of the news. All right. So what we are trying to do is we are trying to model the consequences of the destruction inflicted by flooding or by different types of disturbances induced by climate change. So it could be flooding, but it could be something else. It could be a drought, or it could be some other things that might happen. So we got all sorts of trouble we could start looking at. But the main thing that we focus on is once the trouble has happened, whatever it is, a flood, an earthquake, whatever this is, we model the consequences on critical services, particularly infrastructure services. So let me show you. Typically, was something we have recently modeled in an interactive system that we use to evaluate things. So we have a town, and the town is using all these critical services. So I'm zooming in. Presently, this is an application which, a bit like a dashboard, an interactive dashboard. You can zoom in, you can pan. So these are the different services. Power grid services, gas services, hospital services, and telecommunication, and so on, so on. And here we have a list of critical infrastructure nodes. So a node is basically whatever we can find on the GIS map, which represent a particular point of interest. It could be a coach station, it could be a general medical surgery place, it could be a hospital, it could be a transformer in the power grid, it could be a pump that brings water to the water distribution system. So what happens is everything is linked together, and on top of it, we connect to some statistics about the area. So if we are, for example, in one area, one part of the town, where we have residents that work in hospitals, and these residents happen to be parents of kids which are under 12 years old. If we close all the schools that serve this area, that give the service of primary and secondary school, then some of these parents won't be able to go to work. And that means that if they work in hospitals, you'll have a lesser amount of workforce available. And this in turn will impact how things work. So it's not just the fact that service depend on other services to work properly, but it's also the fact that service depend on workforce availability to work properly. So we combine this. So let me give you an example. This is a list of critical nodes there. And if I'm going to zoom in so you can read a bit better. Let's say I'm going to shut down some pumps, water pumps that provide water to the overall water distribution system. So I'm going to shut down 4 pumps. Let's say there's been a big flooding and the electrics of these pumps is not working anymore. I'm going to click run, and the system is going to simulate the consequences. So you see, you've shut down these 4 pumps. So you've got no more sewerage. You also have a problem with fire rescue, because the fire stations, when they provide the service of fire rescue, they need to connect to a hydrant, a water hydrant in the street where there is a fire. But if there is no more water that comes through the water distribution system to the fire hydrant, then they cannot provide these services in this town. And then you can start seeing that if you close other things on top, then things are going to go down as well. So let's say you start closing primary schools or secondary school in your area. So there's lots of primary school, but if I start closing them down, they will have a major impact on the attendance of staff, because around 17% of staff in places like hospitals or schools or public administrations, places like that, around 17% of the staff are actually parents. And if they cannot come to work because their kids are not going to school, then this will have an impact. So I started to close a few schools, and you started to see some other things going down. So we have also some statistics on the type of industries in which people work and how they are impacted, how the workforce is impacted in all these different industries. This is where it gets really important and interesting, is when you know in advance which nodes have to be protected at all costs. Things that you don't think about normally. Normally you wouldn't necessarily go protect schools, right? But if the schools that you think of are actually allowing 17% of the staff to work in hospital, perhaps this difference in workforce in a hospital will be the difference between, well, life and death in some cases. So yes, we are working on it, and we are refining it and trying to increase the magnitude of the disturbance because of what's happening in the news. So the ARSINOE project is very ambitious, and we had some ideas of lots of things we wanted to do. And what's interesting about that project is we are evolving. We are discovering new things as we go, and we are starting to revise and change what we had in mind that could be accomplished. For example, at first, we thought we would insist a lot on permutation. How, for example, you have a set of infrastructure, dual infrastructure, or things that can be used in different places, and resources, and now you could allocate these resources to repair faster your infrastructure. We thought this would be like a big deal. Although it's not something that's going to necessarily disappear, What came out from stakeholder feedback is that we should perhaps focus a little bit more on preparedness and identifying before the trouble comes what would be the point to protect first. So it's not so much about dealing with the aftermath than first carefully building a strategy of prioritization of the protection of specific assets. And this is what would be more and most useful for professionals which deal with emergencies, from what we've discovered while refining the model with the stakeholders' feedback.